Today I'm going to be talking about a Dell E1705 laptop that I'm going to upgrade. I found this laptop in the recycling at my school, and I wanted to upgrade it to modern hardware. Pretty modern. Not the newest stuff, but it will be good enough for what I'm doing with it. So originally the laptop's shipped with a Core Duo processor, which is 32-bit. It's the T7250 processor running at 1.73 gigahertz, and it ran pretty slow. I mean, that's pretty bad. It couldn't run even a 64-bit operating system, and it was running at 1.73 gigahertz. It was a dual core, so it ran pretty sluggishly. 4 gigabytes of DDR2 RAM. That's the maximum that the E1705 computer operated on, so that was good. Came with no SATA hard drive, integrated graphics card, and a pretty low resolution screen for the size. I think it's a 17-inch screen, 1440 by 900, which isn't that great of a resolution for that big of a screen. So I wanted to upgrade all these specs to make it at least a little bit newer and workable. So just a little bit about Socket M. The E1705 computer ships with the Socket M CPU, Intel CPU thing, socket. It was introduced in 2006, and interestingly enough, it supports a 32-bit and 64-bit processors. It'll be the Intel Core Duo / Solo, which is a single core, and the Core 2 Duo 64-bit processors. And it's only the first generation, the T5X00 and T7X00 processors. So that was pretty interesting that it can support 32-bit and 64-bit. But it comes with a little performance hit, is that the front side bus is limited to the 667 megahertz with the 945XM Northbridge chipset, which the motherboard has. So the CPU can go all the way up to 800 megahertz, but it's limited by the Northbridge chipset on the motherboard, on the E1705 motherboard. But it can go up to 800 megahertz with if it had the 965XM chipset, Northbridge. So after all the upgrades I could think of, I upgraded to the specs. So I found the highest performing Core 2 Duo processor I could get with the same power envelope, and that fit in the Socket M socket. I kept the 4 gigabytes of DDR2 RAM just because it's already the maximum that this computer will support, and that's good enough for the office use. I put a 120 gigabyte SSD in the laptop, so it would boot really fast and load up programs really fast, leading to a very noticeable performance increase. And I put in the Nvidia FX2500M 512 megabyte GPU, which is an external GPU, which you'll see pretty soon in my upgrade video. And I put in the highest resolution screen I could find, which is a 1920 by 1200 TFT screen, which works pretty good. It's a little tiny bit dim, but I think it's a great screen for the laptop. You can fit 2 windows side by side, and there's no big, huge boxes or anything. It's all pretty small and nice. So I'm going to go through the upgrade steps on how I upgraded the computer. Okay, first I tore down the computer, I took out the battery, took out the RAM, took out everything I could think of, like the wireless module, and then I got another screwdriver, thinking, and I started on the case. Just removing all the screws at the bottom, and then I started on the removing the keyboard. I removed this top strip first right here, and then I removed the keyboard underneath it. Pretty standard. I followed the service manual, by the way. So I took off that. There's some screws that are hidden under there, and some cables, and the keyboard's gone. And now you can see the first image of the integrated GPU. This is actually the DVI section of the GPU. And then there's the Northbridge chip right there. This one is, interestingly enough, it's a RAM controller and a GPU all in one chip. So this powered the VGA port, and I think it had some video output, like an S-video port out, which is pretty cool. And this one right here supplied the DVI connection on the computer, and then you can see the CPU right there. So I wanted to strip down the whole computer because I needed to grind the case. The GPU has 2 heat pipes on it, so one heat pipe would go right here, another one goes over here, but the case hasn't been stamped out right there, so I need to grind the case away, which you'll see pretty soon. And the GPU fits right on this section right here. Just keep moving all the screws, trying to get everything off of it. The motherboard wasn't compatible with the GPU I put in because it just didn't recognize it in the BIOS. So I had to get a new motherboard that did support the GPU. A little closer shot of the DVI section of the GPU. And there's just one chip on it. It's a Silicon Image SIL1362 ACLU. And if you go to the data sheet, it's kind of interesting. So here's the data sheet. It's from Silicon Image. Yep, it's a DVI output chip from VGA to WUXGA 1600 by 1200. So the monitor I put in was actually higher resolution than this chip can actually supply. And that's just the block diagram of it. See, it only does DVI out going to the display with all the different channels and stuff linking them together. So kind of a simplistic chip, but it's pretty purpose made for DVI. And here's me sizing up the GPU where it's going to fit in. I actually had to grind out the case over here and over here. So that's why I moved everything off the motherboard, so the magnesium dust wouldn't get in there. Alright, here's a close-up of the panel that wasn't cut out during manufacture, because this computer originally didn't come with an integrated GPU, so there's no need to have the ports cut out right here. Okay, so I'm starting on grinding out the port. Just use a standard Dremel with a sandpaper disc on there, like a grinding wheel. And I'm just putting my isopropyl on there to clean off the oil which I put on there, which I really didn't need. And I'm just going pretty slow, trying to figure out where the grill is. And yep, just keep going, looking to see, make sure I don't puncture through it, mess it up. The magnesium wouldn't catch fire because I'm grinding it right now, which could cause friction. But I tried it in the test piece and it didn't light on fire, so I proceeded with grinding on the computer. And look, it didn't fit on this inner bracket right here, so I had to grind that down a little bit. It's got a bigger wheel on it. It looks like I had to grind a little bit off that other one too, make it fit in. And it looks like it fits now, so proceed on to washing it off. I just used dish soap and scrubbed it pretty good. And then I actually used compressed air to dry it off, which worked pretty good. Dried off pretty good. And I think I just let it dry for a little longer than without anything else. I tried to put the GPU in the original motherboard, but it wasn't really compatible. Doing so, I had to remove this connector which supplied the DVI from the motherboard. With this connector got in the way of the GPU connector, which is right here, and it prevented the GPU from being inserted in the motherboard. So I just cut some hot air and some flux, and I got heated up, and then it finally unstuck after a while of heating up. And then I just cleaned up the board a little bit to make sure there's no solder shorts. Just quickly tinned it, and then I put some solder wick on it to suck up the rest of the solder. Just dabbed it a little bit and got rid of it. And then I finally just cleaned it up after with isopropyl. The motherboard didn't come with the fan header connector for the GPU fan, since it was never designed for a GPU. So I soldered it on. Later I found out the fan didn't even work because some of the circuitry must be missing for controlling the fan. So I soldered that on pretty easy. Tinned it and took off the excess, and then I just soldered it on with the soldering iron. It's pretty easy. Yep, I'm just gonna solder on. Okay, so this is the first computer start that I had with the old motherboard with the integrated GPU in it. As you can see, the laptop monitor has no display, and when I connected an external display to it, a VGA display, it worked. This is partially because the Intel chipset has actually a GPU in it, the Northbridge. Okay, so here's a block diagram of the entire motherboard for the entire computer. So here's the CPU, which is the Core 2 Duo. The system bus is 553/667. We're running at 667 megahertz right now. And this is the Northbridge chip. Memory controller. The memory connects to the Northbridge, which has the internal memory controller in it. And then there's the Southbridge, which does all the I/O, peripherals, everything else. Interestingly enough, there's a GPU inside it. The GM version, the 945 GM, has a GPU in it, and it provides the VGA, the TV out, like analog connection. So that's pretty cool. So that's why the VGA still worked, because it was running off of this chip, and the external GPU wouldn't, because it wasn't detected. It didn't output through the LVDS connector going to the laptop monitor. So I think that's all about that. This it's a pretty extensive schematic online, so it's kind of cool. Look through everything else, everything on it. See if I got a note somewhere about something. All the circuits on the motherboard, which is pretty cool. So I messed around with it trying to get the internal GPU working, or the external one, and the computer just didn't even recognize it. So I'm just trying different things, how to get it to work. Trying to install a driver on it, but it just didn't recognize it. And yeah, right there I noticed that the GPU fan wasn't working. Alright, I think that's all of that. All the video I have. Oops. Alright, So ground the case, watch the case, set a GPU connector. Okay, so the reason why the new display didn't work with the GPU is that the motherboard that did support the GPU has the 945 PM chipset, Northbridge chipset, versus the one that doesn't have an external GPU has an Intel 945 GM chipset, which has the integrated GPU in it with the VGA connector and everything else. How I found the difference is that there is a capacitor missing on the motherboard, which supplied the LVDS connector coming from the Northbridge chipset. And there's a lack of power for the GPU fan, so this motherboard wasn't really designed for an external GPU, even though it had the connector. And there's probably a BIOS configuration which didn't recognize the GPU. So I swapped out the old motherboard for the new one, which I knew did support an external GPU, and it booted up with the new GPU and it worked pretty good. So here's the pictures comparing the two motherboards. This is the new one, which does support the GPU, and then I have the old one right there. So there isn't actually much difference. You can see that this is the C117 capacitor, which supplies the LVDS connector going to the internal laptop motherboard monitor. You can see that's missing right here on the new one, which leads to this not having an internal GPU on it. So all the graphics power it would have to come from the external GPU. I'm not 100% sure, but I think this chip might be missing or added onto the new motherboard versus the one that doesn't support an external GPU. And this actually was after I soldered on a new connector. You can see that it would be missing on the old one. It would be missing if I didn't put it in there. And there's some few components around here which supplied this old connector, which I took off in the picture I took. There'd actually be a connector here which would power the LVDS connector going to the internal display on the laptop. So there isn't actually much difference between the two motherboards. It's kind of cool. There's a few studs missing for the GPU, which were present in the new one, obviously, so it would hold on to it. Okay, so in conclusion, I improved the performance of the computer. It runs quite a bit faster than it did before. It can run a modern 64-bit operating system and everything else that comes with that. I'm running KDE Linux on it right now. I think it's Linux Mint 17 or something, 17.3, and it runs pretty good. It's really stable. I use it as a mobile workstation in case I need to type stuff on the go. It works pretty good. It doesn't really run games too well, but I'm not really getting game on it at all. It does run Minecraft on a small screen, not on full screen, but on a smaller screen. It runs pretty good. I modernized in quotation marks. It's still pretty old technology, the Core 2 Duos, but I think it's good enough for just like office work. And it cost about $130 to upgrade the computer, which I got for free. So I think that was a pretty good result. Seems to work pretty good. I like the media buttons in the bottom, which I can pause and play video. The keyboard isn't the greatest keyboard in the world, but it's sufficient. And the trackpad is pretty sufficient too. I like the dedicated buttons on the trackpad. Unfortunately, it doesn't come with a track point, which would be great to have. But, I mean, it's pretty good for what it is. And I hope you liked the video, and I hope to see you next video.